Welcome to Honors Geometry second semester. I am Mrs. Venner.
And I'm Mrs. O'Brien.
And today we are going to talk about applying Pythagorean Theorem.
So, our goals for today are to be able to identify which side is a hypotenuse of a right triangle and correctly use the Pythagorean theorem to find the missing side lengths of a right triangle. So, if at any time we go too fast, just pause the video and write down what you need to get, or
if you just want to watch us over and over again, feel free to do that as well.
But we are checking your notes tomorrow, so make sure you have everything down that we've covered in this video and the next video. So let's take a look at a triangle. 3 sides, 1, 2, 3, a triangle. So we want to take a look at what kind of triangle this is.
I think it's a right triangle.
Oh, that square right there tells us the measure of that angle is 90 degrees. And we want to look at the side lengths because those are going to be what's important to us for Pythagorean theorem. We have one side length called the hypotenuse. And then we have 2 sides of a triangle, the right triangle, called the legs. And it's really easy to identify which one of the 3 or which 2 of the 3 are the legs because the legs help create that box for the 90-degree angle. So if you see that box, the 2 sides that make it, those are your legs. And that's a really good indicator of which one is which. The hypotenuse is always the largest side, and it's opposite the 90-degree angle. So think about that arrow in the box being the same as the arrow pointing to the side.
And it's important to remember that we are dealing with 90-degree angles, right triangles here. Pythagorean theorem, you have to have a right triangle. So that leads us into Pythagorean theorem, which you all know and love. And it says, in a right triangle, the square of the length of the hypotenuse is equal to the sum of the square of the lengths of the legs. Notice here it says right triangle. So you have to have a right triangle. So that leads us into the formula that you all know and love so much. A squared plus b squared equals c squared. But what exactly does that mean in the context of what Mrs. O'Brien just gave you? You know you have a leg, so we'll say leg squared plus your other leg squared is equal to your hypotenuse squared. So remember, you need a right triangle for this.
So let's take a look at an example. Find the length of the hypotenuse of the given right triangle. So it tells us it's a right triangle. We can see it's a right triangle. It's got that box. So we're going to use our formula that Mrs. Venner just said. Leg squared plus leg squared equals hypotenuse squared. Or the simpler way to remember it, a squared plus b squared equals c squared. So now we've got to take a look at our triangle and figure out which one's which. What are the legs here? And what's the hypotenuse? So looking at our triangle, we've got that right angle. The 2 sides that make the right angle are the legs. So the side length with a 7 is a leg, so we'll call it A. And that is a leg, and we'll call it B. It doesn't matter which one you make A and which one you make B. And our leftover is our hypotenuse, which is C. So we're going to plug those numbers into our formula. Our leg, 7 squared, plus our other leg, 24 squared, equals c squared, which is our hypotenuse. So 7 squared is 49, 24 squared is?
576.
Oh, you didn't need a calculator for that. And that equals c squared. So we're going to add the 2 of these together really easily and come up with 625 equals c squared. C squared. How do I get rid of c squared?
I'm so glad you just asked that because we worked on simplifying radicals today. I believe you have to take the square root to undo a square.
So let's do that. We'll take the square root of c squared and we'll take the square root of 625. Since it's an equation, you have to do it to both sides. Square root of 625, that's a perfect square. So 25 equals c squared and square root cancel out, c. So our hypotenuse is 25.
Wow. It's good stuff.
I know. I like it.
I'm feeling good about it.
Good. Let's take a look at another example. Oh, you know. just leave it.
All right, so we're gonna try a real world problem. It says a 5-foot board rests under a doorknob and the base of the board is 3.5 feet away from the bottom of the door. Approximately how high above the ground is the doorknob? All right, Mrs. O'Brien and I always tell you guys, make sure you draw a picture. So we are going to draw a picture here. We know it's a right triangle, so we're gonna go ahead and draw a right triangle here.
Because a door and the floor make a 90-degree angle.
It's crazy how that works.
I know.
I know. So it says the board rests under a doorknob, so we'll put the doorknob there, and it's a 5-foot board. So that distance there is 5 feet. Then we know that from the base of the board to the bottom of the door, it's 3.5 feet. So we put 3.5 there. Now we know we're trying to find how high above the ground the doorknob is, so we'll call that x. And we draw on a right angle there. So now it's a simple Pythagorean theorem problem. The only difference is now instead of doing leg squared plus leg squared equals hypotenuse squared and trying to find the hypotenuse, we have the hypotenuse, now we're trying to find a leg. However, we're still going to use the exact same formula, so we're going to go ahead and plug that in. So our leg squared, 3.5 squared, plus our other leg squared, x squared, equals our hypotenuse squared, which would be 5 squared. So 3.5 squared is
12.25.
Nicely done. No calculator needed. So 12.25 plus x squared equals, I think I can do this one, 25. I need to solve for my x squared or get my x isolated, so I need to subtract 12.25 to the other side. And I get x squared equals 12.75. And then how do I undo a square again?
Take the square root.
Ah, that's right. So I'm going to square root both sides. So I have the square root of x squared equals the square root of 12.75. And I get that x is approximately 3.6 feet. Now, how do I know whether it's approximate or an exact value? Mrs. O'Brien, any ideas?
Well, we got to look at the context of the problem. And in our directions, it says approximately, so we got to follow our directions. But we also want to look, it's a real world. If I have the doorknob from the base of the door is 12 square root of 12.75, I don't know how much that is. I can't measure that. But if we say it's approximately 3.6 feet, that totally makes sense. I could measure that out. So you really have to look at the context of the problem.
Absolutely. And the other thing you have to think about as well is when you're just taking a look at these and kind of checking your work and making sure you have the right answer, you always want to look and see whether your answer makes sense. So if we're talking about one of the legs being 3.6 feet, in the context of the problem, I got to make sure that that's smaller than the hypotenuse. It is, so I have a pretty good indicator that I have the right answer. And why does that have to be smaller than the hypotenuse, Mrs. O'Brien?
Because the hypotenuse is opposite the biggest angle, so it has to be the biggest side.
Ah, that makes complete and total sense.